Alright, Algebra 1, Part 1. Welcome to our last section of 512. I know it feels like we've been on Chapter 5 forever. Factoring is so important though. This is our last section. We're going to actually be solving equations by factoring. So we're going to be having, instead of like all the simplifying we've been doing and just kind of expanding stuff out, we're going to expand stuff and then actually get an answer based on that. Alright? So the directions are going to be solved. So let's start with our first problem. Alright? So let's say you get... Sorry, guys. So the first two are going to be very, very easy. These are going to be like, you should be like, give me questions. So let's say I get n plus 1 times n plus 9 equals 0. So they're always going to be an equal sign, equals 0, or you have to get it equal to 0. So if it's already equal to 0, leave it. If it's not equal to 0, we'll have to get it equal to 0, and we'll get to those problems in a second. But let's say I get this problem like this first. Okay, here's the thing. It's already factored out for you. If it's already expanded out like this and it looks like something, remember we got to this point? If it already looks like something at this point where we can't simplify it anymore, then we're already almost done with our problem. Now in order to solve this, so let's say this was factorable, okay? Once we factor it, we get to this point. Once you get to this point, the next thing you have to do is you're going to set each piece equal to 0. So if it's already expanded out for you and like this equal to 0, all we're going to do is we're going to set each piece equal to 0. So I'm going to set my answers. So I'm going to set m plus 1 equal to 0 and m plus 9 equal to 0. So we're going to solve here. So I'm going to subtract 1. So I'm going to get n equals negative 1. Subtract 9. N equals negative 9. There's my two answers. Negative 1, negative 9. That's it. Pretty easy, right? Alright, well let's say you take a greatest common factor out. So let's say I took a greatest common factor out and then I expanded it. So they show you this example. They show you 15n times n plus 15 is equal to 0. So let's say I actually, instead of like factoring like this, let's say I took a greatest common factor out and then I factored like this or whatever. So I'm left with this, right? So this, if it has a variable with it, is part of my solutions, okay? So let's say I took a greatest common factor out and it has a variable with it. I have to still set this equal to 0. So the number in front, so let's say I took, I don't know, like 2x squared out. I still have to set that equal to 0 as well as the things in parentheses, things in parentheses. So I'm still going to have two answers here, okay? So here I'm going to divide by 15. This can happen. I can't divide by 0, but I can do 0 divided by anything. It's just 0. So 0 is one of my answers, and negative 15 is my other answer. Alright? This is just the key. So if I just factor something out, I set each piece equal to 0. If I take greatest common factor out and then keep expanding, my stuff that's expanding like this, I still have to set equal to 0, as well as if the thing I took out has a variable with it. If it's just a whole number, leave it. But as a variable with it, I still have to set it equal to 0. Everything has a variable with it. Every piece is set equal to 0. Alright? So these two, not too bad. All right, let's move on to the next few. All right, so number 3. All right. So number 3, let's say we have, to show you, it's 2t minus 3 times 3t minus 2 equals 0. Again, pretty easy. It's already expanded out for you. I can't do anything else with these. It's already factored out. All I have to do here is set each piece equal to 0. So I set 2t minus 3 equal to 0 and 3t minus 2 equal to 0. All right, this is going to take a little extra work. So here I'm going to add 3. So 2t equals 3. Divide by 2. So t is going to equal 3 over 2. That's one answer. The other answer here is I'm going to add 2, right? So I get 3t equals 2, divide by 3, so t equals 2/3. So t equals 2/3 and t equals 3/2. Done. Two answers. All right. So let's jump right on to number 4. So that's really it. So if it's already factored out, pretty easy. All right, so now you see something with y squared. Okay, we're going to actually do something here. So number 4, you have y squared minus 3y plus 2 is equal to 0. Okay, so the first thing we have to do here is we have to actually factor this. So remember, to factor, I need to figure out, this number is less than, is 1, so we can factor this just easily. Two numbers that multiply to get 2 and add to get negative 3. What it's going to be is going to be y minus 2, y minus 1, y minus 2. Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3. Okay, so once we factor it out, now this was like my first couple problems I started with. Once I factor it out, now I'm just going to set each piece equal to 0 and solve. So my two answers are going to be where y minus 1 equals 0 and y minus 2 equals 0. So here my two answers are going to be 1 and 2. And if I set 1, so the way to check your answer is if I put these, either of these numbers, if I put 1 in here or 2 in here, I should get the answer of 0. So that's your way to check. If you're unsure if your answer is correct, plug these numbers back in. If they give you 0, great. If they don't give you 0, try again. All right, so let's jump right into the next one. So again, it's like we've been doing, it's factoring, but now you're getting an answer. So now you're using factoring to get an answer, okay? All right. So number 5 looks a little weird, but I promise it's nothing crazy. So you get 0 equals x squared plus 14x plus 48. The only difference between this problem and the problem we just did is the zeros in front. That's the only difference. All right? The only difference. So it's just 0 equals instead of x squared plus 14x plus 48 equals 0. So you just do the same thing. So I'm going to factor two numbers that multiply to get 48, add to get 14. If I did that, it's going to become x plus 8, x plus 6. Why is that? 8 times 6 is 48, 8 plus 6 is 14. Now to get my answer, I'm going to set each of these equal to 0. So I'm going to set x plus 8 equal to 0 and x plus 6 equal to 0. Solve here, so I'm going to get x equals negative 8 and x equals negative 6. And if I plug in negative 8 or negative 6 into my number 5, I will get the answer of 0. And that's the whole thing. You're trying to find out where this equation is going to equal 0. It equals 0 at negative 8 and negative 6. All right, not too bad so far. All right, we're halfway done. Let's jump to number 6. So you get m squared minus 36 equals 16m. All right, so the first thing we're going to do here is, you notice, what happened? Every other problem was set equal to 0 already. So the first thing we have to do here is we have to get this problem set equal to 0. What I always do is, and my biggest thing I can tell you is, always bring everything over where the squared term, or make the squared term positive. Always make sure whatever it is, m squared, x squared, y squared, z squared, make sure it's always positive. Get everything over on one side where this is going to be positive, okay? I just promise you it'll make everything easier. So I'm going to bring the 16m over here with everything else. So I'm going to subtract 16m on each side. Now what I'm going to do is I'm going to rewrite this m squared. I'm going to put the 16m in the middle just like everything with, so I'm just going to write minus 16m minus 36 equals 0. Because when I subtract those two terms, that becomes 0. What I did was I put the negative 16m in the middle just so it's rewritten like all my other problems so that I'm not confused. So my whole number, my one with the one variable, and then my squared variable. All I do is just put it in the middle. It's still negative 16 like I subtracted it over. It can't subtract everything, there's no like terms over there. So now I have to find two numbers that multiply to get negative 36 and add to get negative 16. All right, if I go through my different factors, I would get to, so let's see, 36. You got 1 and 36. 2 and 18, right? So this would be negative 18 and positive 2. Negative 18 times 2 is negative 36. Negative 18 plus 2 is negative 16. All right. So now to find my answer after I factor, I'm just going to set each piece equal to 0. So I'm going to get m equals 18 and m equals negative 2. Two answers. again, the key here is that, so again, first thing you want to do, get it set equal to 0, then factor if you can. Once you factor it out, set each piece equal to 0. Those are your 3 steps. Get it equal to 0, factor it out, factor it out and equal to 0, set each piece equal to 0, there are your answers. Alright, and if it's already factored out, of course, just set each piece equal to 0. Depends on where you're at. In this case, we had to do 3 steps. Sometimes it might be 2 steps. Sometimes it might just be 1 step. It might just be setting each piece equal to 0. So it's just going to depend on the problem. Alright, so a few more. The most steps I'll have to do is 3. So that's not too crazy. Alright, so let's look at number 7. So you get s squared equals 4s minus 32. Okay, what do we see? Neither of the sides are 0. We have to make sure one of the sides are 0. What else did I say in the last problem? Make sure I want to bring everything over to where my squared term is positive. So what am I going to do here? I'm going to subtract 4s and add 32. Bring them over here. So I'm going to have s squared minus 4s plus 32 equals 0. So I brought everything over to where the squared term is positive, okay? All right, now once I do that, of course, now I got the one side equal to 0. Now I'm going to factor, right? So what multiplies? So it's going to be s minus 8 and s plus 4. Negative 8 times 4 is negative 32. Negative 8 plus 4 is negative 4. Cool. All right, so now once we factor, what do? We set each piece equal to 0 and get our answers. So I'm going to set s minus 8 equals 0. S plus 4 equals 0. So this is going to be s equals 8 and s equals negative 4. There's my 2 answers. Beautiful. All right, guys. Just a couple more. All right, so number 8. So now you get y squared equals 16y. You're like, whoa, this is different. There's not 3 things, only 2 things. What am I doing here? Again, first thing, get it set equal to 0. Bring this over where the squared term is positive. So I'm going to subtract 16y on each side. So I'm going to get y squared minus 16y equals 0. Cool. Now you're like, I don't know what to do here. You're like, it's not like a normal factoring problem. It's only got 2 things. It looks like differences of squares, but 16y is not a perfect square. Well, let's see. If that doesn't work, what do they both have in common, right? They both have at least one y. So let's take that out and see what happens. All right, well, when I do that, right, I took out a y. They both have a y in common. I'm left with one y here and then just 16 here. I can't do anything else with that. So I have 2 pieces here, right? I think it was the second problem. We had something where we had this and we had something else. That's it. That's all we can do. So my 2 answers here, I'm going to set y, the y in the front, equal to 0. Then I'm also going to set y minus 16 equal to 0, which is going to be 16. So basically what they're saying here is if I put 16 in here, or I put 0 in here, or I put it in here, either way, it's going to be equal to 0. So if you're checking your answers here, I'd put it into the one where I set equal to 0. So I would plug negative 8 and 4 into here, it's going to work. And I'd plug 0 and 16 into here, and it's going to work. That's what we do for number 8. All right, so 2 more. Not too bad, I hope. I mean, it's all the factoring we've been doing. It's just this new thing of actually getting an answer, which we haven't gotten yet. All right. So 9 and 10. The last 2. All right, so number 9, you get 4x squared minus 9 equals 0. All right, so this is already set equal to 0. Cool. So that step, we're already done with that. We don't have to do what we did number 8. But you're like, how do I factor this? Okay, well, if you tried 4x squared, if you try to square root it, 4x squared is a perfect square, as well as 9. Well, because they're both perfect squares and they're subtraction, this is difference of squares. Remember how we do that? It's 2 sets of parentheses. It's the square root of this first number, which is 2x, and then plus or minus the square root of the second number, which would be 3. All right, so that's how you factor difference of squares. All right, so now it's all factored, done, nothing in the front. I'm just going to set each of these equal to 0. So I'm going to set 2x plus 3 equal to 0, and 2x minus 3 equal to 0. So here I'm going to get x is equal to, so let's solve this, right? So here I'm going to subtract 3. So I'm going to get 2x equals negative 3. So I get x is equal to negative 3 over 2. And then here I'm going to add 3. So I get 2x equals 3. Divide by 2, and x equals 3 halves. So I get x equals 3 halves, and x equals negative 3 halves. Thought if I could write 3 halves a little neater. I think you guys get the point though. So x equals 3 over 2 and negative 3 over 2. Beautiful. So that was just difference of squares. It's a good practice to remember all our factoring tools. Alright, so one more. Number 10. This is probably the toughest one, I'll say. I just made it like those harder factoring problems. So let's say you get 6n squared plus n equals 2. You have this on your sheet. Okay, so the first thing I do, get it set equal to 0. I think we got that down. So I'm going to bring the 2 over, everything where the squared term is positive. So I get 6n squared plus n minus 2 equals 0. There's no greatest common factor here, but the number in front of n squared is greater than 1. When that happens, we have to do factoring by grouping. So we do that ABC method, right? So we got A is 6, like 5, 9. B is 1, C is negative 2. So we multiply the first and last numbers, and we got the middle number. So reminder, we need two numbers that multiply to get AC and add to get B. So that multiply to get AC and add to get B. These two numbers would be 4 and negative 3, right? 4 times negative 3 is negative 12. 4 minus 3 is 1. Remember how I factor this. I rewrite the first number. You can leave the equal 0 out, but write the second. Rewrite that as plus 4n minus 3n minus 2 equals 0. So all I did was I split the 1n into 4n and 3n. Remember, I leave the first and last number the same. All right, now I'm going to group the first two, group the last two. Here I can take out 2n. So I'd be left with 6 divided by 2 is 3n plus 2. Here to make these both positive, I can take out a negative 1, right? Negative 3 divided by negative 1 is positive 3n. Negative 2 divided by negative 1 is positive 2. So this fully factored out, guys. Sorry, I'm going to need a little more room to shot. So remember, to factor this out, now we're going to need the equal 0 back. I just eliminated it for that time being. So this fully factored out, guys, remember, is the front numbers, so 2n and minus 1, and then the other thing, 3n plus 2, that's going to be equal to 0. So that's it fully factored out. So we got it set equal to 0, we factored it out. Now we just got to find our answers. So we're going to set 2n minus 1 equal to 0, and 3n plus 2 equal to 0. All right, so here I'm going to get n equals 1/2, right? So I'm going to add 1, divide by 2, n equals 1/2. Here I'm going to subtract 2, of course the opposite. Divide by 3, so n is going to equal negative 2/3. There's my two answers, 1/2 and negative 2/3. So that is solving equations by factoring. So what we've been doing, we're just setting it just has an equal sign in it now. If you have any questions, please let me know. I hope you guys have a great day.